Select all of the following tables which represent y as a function of x and are one-to-one. So for a set of points to be one-to-one, it has to pass both a vertical line test and a horizontal line test, just like the graph of a function would. Because the graph of a function is just a set of points, it's just that there are so many, it produces a line or a curve or what have you. But if we were to take the first set, for instance, and graph them, so I'll just graph them very quickly here. So 5 and 3 is the first point, so I'll just say this is 5, and say that's 5 as well, so 5, 3 would be about right here. Then 6, 9, so if that's 5, I'll say this is 6, and then 7, 8, 9, so that point would be right there. And 6, 12, so 10, 11, 12. All right, so this point would be about right here. So the vertical line test says that if there is a vertical line which passes through the graph, or the set of points that is, at more than one place, then it's not a function. So that happens here. So this set of points is not a function. So if it's not a function, we're not even going to include this as the set because we want it as a function and one-to-one. Technically, it passes the horizontal line test because any horizontal line would only pass through a single point at one time. But if it's not a function, we're not concerned with it being one-to-one. We're just concerned with it first being a function, and then if it is, checking to see if it's one-to-one. So the next set of points, if I were to graph these. So in this particular case, it looks like I have the same basic setup. This time I'll just say 5, 10, 15, 5, 10, 15. There we go. All right, so 5 on the y, or 5 on the x, 3 on the y. There's one point. Then 6, 9. So 6, 9 would be about right there, I suppose. And then 11, 12. So 11 would be here, and 12 would be about right here. So this set of points, any vertical line that I drew would only pass through a single point at a time. So it is a function. So it passes the vertical line test, and it also passes the horizontal line test because any horizontal line I draw would only pass through a single point at a time. So this passes both the horizontal and vertical line test, so therefore this is a one-to-one function. So part B we would include as part of our answer here. And C, the last set of points, let's see what happens here. So then this set of points, we have, I'll get my scale back on here. All right, 5, 3 again, so that point. 6, 9, so that point. And 11, 9, so 11, 9. And the problem here is that this does not pass the horizontal line test. So even though it passes the vertical line test and it is a function, it's not a one-to-one function. All right, so we won't include this set, part C, either. Another way you can think about these things is through the bubble charts. So for instance, if we look at the bubble charts for part A, and what happens here is we have our domain x and our range y. So our domain includes the points 5 and 6. Those are the only two different points. The range includes 3, 9, and 12. 5 maps to the point 3, 6 maps to the point 9, and to the point 12. So we can see that based off of this mapping, because we have one point in the domain which maps to more than one point in the range, it's not a function. In part C, if we did the same thing, you could see there the different points in our domain would be 5, 6, and 11. And then we have in the range 3 and 9. So 5 maps to 3, 6 maps to 9, and 11 maps to 9. So it passes the test for a function because all of the values in the domain correspond to exactly one item in the range. But the reverse is not true. So you could use one of these bubble charts as well. What you're looking for a one-to-one function is something like we see in B, where we have 5, 6, and 11 corresponding to 3, 9, and 12. So there's just a single mapping from each point over to the other point in the range.